Good afternoon, students. Uh, I'm going to start the new chapter, chapter 2, polynomial from today, and we'll take exercise wise. And I'm expecting that you people will like this video and you will share, as well as since I'm going to continue videos, so please subscribe. So, topic is polynomial. Firstly, polynomial. So, children, firstly we should be knowing what is meaning of polynomial. What is meaning of polynomial? Poly means many term, any algebraic expression in which each term the power of variable is non-negative integer. So polynomial basically it can be divided, it can be named on basis of two things. One is on the term basis, second on degree basis. So if only one term is here, number of term 1, this is known as monomial. If number of two terms is 2, this is binomial. 3 terms, this is trinomial. N terms, this is polynomial. So polynomial can be categorized on the two basis. One is the term basis, another is on the degree basis. When a polynomial is containing only one term, like x power 100, only one term, this is monomial. This is binomial, x power 5 plus x, this is two term, binomial. Trinomial means having three terms, x square plus x plus 5, this is trinomial. Polynomial means we are taking here many terms, so this become polynomial. See, and similarly on the basis of degree, if we have only one degree, this is known as the linear. So degree 1, this is linear polynomial. Degree 2, quadratic. Degree 3, this is cubic. Degree 4, biquadratic. So on the basis of term, we can have the name: one term monomial, two term binomial, three term trinomial, and polynomial. So polynomial, general form of the polynomial we can have here. For example, a0, a1x, a2x2 plus a3 x power 3 and so on, an x power n. So this is, it has n terms and degree is n. So degree of this polynomial is, degree of this polynomial is n, and number of term is also n. So on basis of two things, term and degree, we can classify polynomial in this way. let us take the topic which we are going to study in class 10th, the basic things, basic concept which we have to study for the this exercise. So polynomial, any polynomial of degree n this is a0 a1 x power n plus a2 x power 2 plus a3 x power 3 and so on an x power n, where an not equal to 0 is called a polynomial with degree n, and a0 a1 and so on an are real numbers and each power x and each power of x is non-negative number x power. So polynomial, any polynomial of degree n, a0, these are the real numbers, a0 a1 x power 1, a2 x power 2, a3 x power 3 and so on an x power n, where an is not equal to 0 is called a polynomial. Since x is having power n, this shows the degree of polynomial is n. What are these things? a0, a1, a2, a3, an. What are these things? So a0, a1 and so on an are real numbers. And since this is a polynomial, this is very important condition here, the power of variable in each term must be a non-negative integer. Now, question is arising here, what next concept is required for this chapter? If any polynomial we are having, so zeros are required, value or zeros are required. So zeros and relationship between zeros and coefficients, so zeros, 0 oblique zeros, only one zero, this is 0, more than 1 0, this shows zeros. So now it is clear, in the polynomial, firstly we should be knowing what are the zeros. One is the numerical values, another we have to explain this zero with the help of the geometric representation. And what zeros are coming, so we have to establish a relation, that what is the relation of the zeros and the coefficients of the variables. So let us take the next concept. Suppose a polynomial is x square plus 5x plus 4. Suppose this is a polynomial. Yes. What is value of this polynomial at x is equal to 2? So this is value of this polynomial at x is equal to 2. So P2 is equal to 2 square plus 5 into 2 plus 4. So this is 4 plus 10 plus 4, that is 18. So this value is coming P2. This is value of this polynomial at x is equal to 2. At x is equal to 2. Similarly, when we keep any value for x and result is coming 0, let px is equal to x square minus 4. So what are the zeros? What are zeros? Why I am asking zeros? Since degree is here, degree 2, so maximum number of zeros are 2. So degree is 2. So maximum number of zeros will be 2. So this is the reason we are in position. If the degree is 3, maximum number of zeros will be 3. So if I am taking here x square minus 4, this will be here x minus 2 and x plus 2. So either this will be 0 or this will be 0. So when x minus 2 is equal to 0, then x is equal to 2. It means this is first 0 from here. Similarly, when x plus 2 is equal to 0, then x is equal to minus 2. For this quadratic polynomial, we are having two zeros, first 0 and second 0. So this is the way how to find zeros. But before going to start this, there is one important presentation, that is geometrical meaning of zeros of a polynomial. So is this clear? What is meaning of zeros? When a value, this if we are putting over here and this is going to, if we are putting this value in this polynomial, then this will be equal to 0. Similarly, another value if I am keeping over here, this is again going to 0. For verification, if I am keeping here P2 means 2 square minus 4, that is 0. So P minus 2, again minus 2 the whole square, minus 4, and this is 4 minus 4 is equal to 0. So this is 2 is 0 for this polynomial as well as minus 2. So next is geometrical meaning. Geometrical meaning of the zeros of a polynomial. Geometrical of a zeros of a polynomial. So this is a quadratic polynomial, ax square plus bx plus c. Y is equal to, let. This is a quadratic polynomial. Y is equal to ax plus c. This is a linear polynomial. Y is equal to ax cube plus bx square plus cx plus d. This is a cubic polynomial. Since this is a quadratic polynomial topic, so what is required here? We should be taking here तो geometrical meaning of zeros of a polynomial. Case 1, ax plus b. To graph of this be a straight line. This is x-axis. So this is x-axis. This is graph. So graph of a linear polynomial is straight line. Straight line. While graph for a quadratic polynomial, this is ax square plus bx plus c. So there are the few cases. This is like upward, this is downward. So when a is greater than 0, so case 1, when a is less by 0, this is case 2 figure. Means this parabolic graph will be open upward when coefficient of x square is greater than 0, and this parabolic will be open downward when coefficient of x square is less by 0. So is this clear? Means the graph of a quadratic polynomial will be a parabolic structure. So this structure is known as the parabolic. And if it is open upward, this indicates that coefficient of x square is greater than 0. And if open downwards, it means a is less by 0. So clear? So these are the figures by which we are in position to explain the nature of quadratic polynomial. Let us take few more question presentation. Case 2, when graph. Case 1, when this is a open downward, this is open upward. Case 2, this can have and this can have, this is case 2, number of zeros is equal to 2, number of zeros is equal to 1. See, this is what, when graph of a quadratic polynomial intersects at how many points on the x-axis? The number of points will be number of zeros. Since this graph intersects at the 2 point on x-axis, 1 and 2. Similarly, in this graph again this parabola intersects x-axis at 2 points. So maximum number of zeros can be obtained from these two figures are 2. Similarly, in case 2, this just touches the x-axis at 1 point, and in this figure here it is also intersects x-axis at 1 point. So number of zeros are 1. We have few more cases. Case 3. So this is like this. Another graph, this is like this. No zeros. Since this graph is not touching over here, since this graph is not intersecting x-axis, so there is no point common for this graph as well as x-axis, so therefore no zero. So with the help of geometrical representation or graph, we are in position to tell that what is number of the zeros in the given polynomial. So this was the first concept which we should be taking here to explain that when the figures are given, so how we can find. Similarly, if a graph is like this, this is x-axis and y-axis, and this is suppose graph. So it intersects x-axis at 3 points. This is 1, this is 2, and this is 3. So number of zeros is equal to 3. So whenever figure is given and they are asking to find the number of zeros, we should be knowing the graph where it intersects x-axis. How many points, at how many point the graph is going to intersect. That much number will be the number of zeros, and this point will be value of the zero. So is this clear? Okay students, let us take few examples. Suppose for quadratic polynomial, let px is equal to ax square plus bx plus c if zeros are alpha and beta, then sum of zeros will be alpha plus beta is equal to minus b upon a. Minus b is, this is coefficient of x square upon coefficients of x. Product of zeros is alpha into beta, that will be equal to C upon A. C is a constant value. It means constant term upon coefficients of x square. Let us take one example. So we'll continue this concept in the next video. Till then we have to complete our exercise 2.1 and 2.2. Let us take one question, one example here. Like Px is equal to, example 1, this is 2x square minus 5x minus 3. Find zeros and verify the relationship between zeros and coefficients. So this is a quadratic polynomial. Firstly, we should find factors of this polynomial. 2x square minus 6x plus x minus 3. 2x x minus 3 plus 1 x minus 3. This is common in both. Firstly, what is required? We should use, this is A, this is B, and this is C. The product of AC will be minus 6 and B is equal to minus 5. So we should be breaking this number. We should find the two factors of minus 6 in such a way their sum is minus 5 and their product is minus 6. Now, what is common in both? X minus 3 and 2x plus 1. For zeros, either x minus 3 is equal to 0, then x will be 3, or 2x plus 1 is equal to 0. It means x is equal to minus 1 by 2. So we can say, suppose this is alpha and this is beta. Now verification is required here. Verification, alpha plus beta, that is 3 minus 1 by 2 is equal to minus 5 by 2. So this is 5 by 2 is equal to 5 by 2. This is verified. Second, alpha into beta is equal to C upon A. So this is 3 into minus 1 by 2 is equal to minus 3 by 2. So minus 3 by 2 is equal to 3 minus 3 by 2. Hence verified. So in the next video we'll discuss exercise 2.2 and 2.3. So please see this and try to find solution for the next exercise. Thank you.